my beautiful students. I know you are preparing well for your board examination and only few hours left for that, and in this peak moment I came up with all name reaction that you can expect in your upcoming PU examination. So basically this particular video is not going to be a lengthy one, very short and precise video, and these short precise video can give you 10 plus marks because few name reaction that I have included here that can be asked directly in your examination, or sometimes maybe in form of some MCQ, maybe in the form of some 2-marker question, some 3-marker mechanism in fact, because SN1, SN2, all those mechanism also I have included here. So yes, make sure that you are watching till end, only hardly 20 minutes video it will be. So make sure you are watching this until the end, and yes, make sure you are getting that 10 plus marks that is coming out of this particular portion. So yes, without further delay, let's get started. You can see the first reaction is aldol condensation. So aldol condensation, definitely it's a condensation type of reaction that usually we perform in carbonyl moiety. So you can have either aldehyde or you can have ketone, and definitely this particular reaction will give you some beta hydroxy ketone type of unit, and from that you can get alpha beta unsaturated carbonyl. That is the major product that you can get out of aldol condensation reaction, and the reagent of this reaction is dilute NaOH. The aldol reaction can be self aldol and cross aldol as well. Let's proceed. Here you can see the carbylamine reaction. The carbylamine reaction is something, it's performed in primary amine. It's a test that tells us, yes, my particular compound is containing primary amine. So what do you have to give? We have to give chloroform and KOH, and we will get some foul smell after the reaction. So that indicates the preparation of isocyanide at the end. Let's proceed. Here comes the Cannizzaro reaction, very important type of reaction, disproportionation reaction. Here the main important fact that I want to highlight is Cannizzaro is given by only those aldehyde which are non-enolizable, means which are not having any kind of alpha hydrogen, okay, but whereas it was in the case of aldol, it must need the alpha hydrogen, but in Cannizzaro it's not needed. And here actually as a reagent you need concentrated or 50% NaOH, and this aldehyde will be oxidized and reduced simultaneously to give you the alcohol and the carboxylate unit. Let's proceed. Here you can see this is a reduction reaction, Clemenson reduction. If you are having Carbylamine unit, then zinc amalgam in presence of HCl. The reagent is very important. Sometimes they ask in the direct MCQ question as well. So it will be converted to normal hydrocarbon. Next you can see this is the ATAR reaction, a very important reaction. The reagent also sometimes they ask. So if you start from the toluene, your reagent is CrO2Cl2 and you will end up with the benzaldehyde. Next you can see Finkelstein reaction. So Finkelstein reaction is definitely you have to start from the alkyl halide. You have to give Ki. Okay, you will get alkyl iodide at the end of the reaction. It's a basically halogen exchange reaction. Okay, so Ki and acetone is the reagent, and you will end up with the alkyl iodide. I guess it's clear. Next we can proceed with the Friedel-Crafts alkylation. So Friedel-Crafts we have two type of reaction. One is acylation and another one is alkylation, and this is an electrophilic substitution. So here basically what happens, in this benzene ring you can add any kind of alkyl halide in the presence of AlCl3 or FeCl3 as a catalyst. Okay, then that alkyl unit as a electrophile will attack on the benzene ring and you will get the substituted benzene. I guess it's clear. Let's proceed further. This is Gabriel phthalimide reaction, super duper important, and this Gabriel phthalimide reaction will give you the primary amine, and only primary amine you can get out of this reaction. Okay, so here you can see you have to start with the phthalimide, then you have to proceed with KOH, then further once the salt is made you have to give some alkyl halide. So now you will get N-alkyl phthalimide. After that From here, if you just give a little bit acid or base, you will end up with the primary amines. I guess it's clear. Let's proceed. Here you can see Gattermann reaction. Gattermann reaction is nothing but you are having the benzene diazonium chloride. From there you can just substitute it with the Cl. Okay, so what you have to give? Cu plus in presence of HCl. Okay, let's proceed. This is the Gattermann-Koch reaction. Okay, so here what you have to give? You have to give simple benzene and CO, carbon monoxide, and in presence of HCl, and you need some LCl3 and CuCl as a catalyst. You will end up with the benzaldehyde. Next you can see we are proceeding with the Raymer-Tiemann reaction. So Raymer-Tiemann reaction, you definitely have to start with the phenol, and in phenol you have to give chloroform and NaOH, right? And as a result of this, the most important thing that benzaldehyde, orthohydroxybenzaldehyde is one of the major product that you will get out of Raymer-Tiemann. Definitely para substituent also you will get. Okay, let's proceed. This is Rosenman reaction, one type of reduction reaction. So basically we are giving hydrogen in presence of palladized BaSO4, that is the reagent of it, and here what is happening, acyl chloride means COCl is getting converted to aldehyde, RCHO. Okay, let's proceed. Here you can see this is a Sandmeyer's reaction, very famous reaction. Copper must be in +1 oxidation state, so sometimes we may use Cu2Cl2, that is also copper in +1 oxidation state. Okay, so copper salt you need as a catalyst. So as a result of this, what will happen? Entire N2Cl of the benzene diazonium chloride will go and one halogen unit will come out there. Okay, let's proceed. Here you can see Stephen's reaction. So Stephen's reaction is another important, where nitrile gets converted to aldehyde. So what's your reagent? Your reagent is SnCl2 and HCl in presence of water. Okay, so your benzonitrile will be converted to benzaldehyde. Okay, let's proceed. Here is Swarts reaction. So Swarts reaction, it is also a halogen exchange type of reaction. You can use like any kind of catalyst, like you can use a AGF, HGF, this type of thing, and it will give you some alkyl fluoride at the end. Okay, let's say here one example, methyl bromide you started, AGF you gave, and you are ending up with CH3F. I guess it's clear. Let's proceed. This is Williamson ether synthesis. It is an SN2 type of reaction that can form both symmetrical and asymmetrical type of ethers. So what is basically going to happen? This is going to be performed as a nucleophile. This O minus will attack on this R and this X will be left, right, as a living group. So you will get ROR, means one ether type of unit. I guess it's clear. Let's proceed. Here you can see Wolff-Kishner reaction. So whenever it comes to Wolff-Kishner reaction, the reagent is very much important. Sometimes they ask in the question directly that any kind of ketone if you are having, then if you have to use you have to use hydrazine as a reagent in presence of any strong base like KOH. Okay, and you can use very high boiling protic solvent you can use, that will give some benefits to the reaction, and you will end up with the hydrocarbon, means that double bond O will be reduced completely with hydrogen. Next, Wurtz reaction. Wurtz reaction is one of the most famous reaction for the board examination. So it's basically a coupling type of reaction. So alkyl halide in presence of sodium, it forms alkene. Two alkyl unit gets attached, gets coupled up, right? Next, Wurtz-Fittig reaction. So Wurtz-Fittig reaction, you are having one alkyl halide, another aryl halide. So the reaction between alkyl halide and aryl halide in presence of sodium metal, okay, will give you R substituted benzene. Okay, that is Wurtz-Fittig reaction. Now here you can see that is a HBZ reaction, Hell-Volhard-Zelensky. That is a kind of halogenation reaction, okay, where the halogenation will take place at the alpha position of the carbonyl of carboxylic acid unit. Okay, alpha position of the carbonyl of the carboxylic unit. Okay, so reagent you can give Br2 PbR3 heat and like H2O you can give, and you will get the alpha halo substituted carboxylic unit. Okay, so this is your HVZ reaction. Sometimes in the board also they ask this question, and the reagent also is very important. Next you can see Hoffmann bromamide reaction, very important reaction for the board as well. So here what happens, you are having one amide unit. Okay, it reacts with bromine in aqueous solution of sodium hydroxide. Okay, and it produces primary amine. Okay, so this is a degradation type of reaction, and you can expect the product with one carbon less, because you can see this C double bond O, this particular carbon is not reflected in the product. So the product that you will get after the degradation type of reaction, that will be of one carbon less step down process. Okay, I guess it's clear. Let's proceed. Please focus whenever I am telling what is the starting material, what is the reagent, and what is the product. That's it. Next, here you can see it's Kolbe's reaction. So Kolbe's reaction is something you have to start from the phenol. You have to treat it with NaOH and CO2, and then you will end up with salicylic acid, that is orthohydroxybenzoic acid. Okay, very famous reaction, and it comes in the examination as well. Okay, so all the name reactions are covered, super duper important name reaction for both second PUC and your KCET examination. Now we will proceed a little bit towards the important mechanism that you must know for your the board examination and for your KCET as well. So let's proceed with the first one, that is the SN1 mechanism. So SN1 mechanism we are trying to do in tertiary butyl bromide. Okay, so in tertiary butyl bromide, what happens at first, like SN1 reaction, it happens in two steps. Okay, in the first steps the leaving group leaves the system and it gives you the carbocation, and in the second step that carbocation is getting attacked by the nucleophile. Okay, so in the first step what is happening, Br leaves, and it is a stable system. From a stable system it is making an unstable intermediate, that is a carbocation. That's why the first step is really slow, and it is the rate determining step. Okay, so this is the rate determining step, and it's the slowest step where the carbocation is generated. Okay, so stability of the carbocation is one of the major fact to make the reaction faster. So here comes the role of the solvent as well. So if you use a polar solvent like water, then it can make the carbocation very much stable. Okay, now in the second step what happens, basically the nucleophile attacks on this carbocation and you will get your tertiary butyl alcohol. So one more thing that I wanted to tell, that carbocation gets stability in case of 3 degree maximum, then 2 degree, then 1 degree. So if you take one tertiary butyl unit, then your chances of SN1 reaction to be faster. Okay, and one more thing, that it is a fast order reaction, because the rate of the reaction depends only upon the concentration of this particular starting material or tertiary butyl bromide only. Okay, I guess it's clear to you. One more thing that I wanted to mention here, if you want to proceed SN1 reaction with an optically active alkyl halide, then you can expect an racemic mixture as a product. So the product is R and S mixed, the racemic mixture. Okay, so this is all about the SN1 mechanism. Let's proceed a little towards SN2 mechanism. SN2 mechanism is quite simpler. It's a single step concerted mechanism. So what basically happens, in a same step the leaving group leaves the system and the nucleophile attacks over there. Okay, and as a result of this you will get a penta-coordinated transition state in between. Okay, so what is basically penta-coordinated transition state? Here the leaving group is also partially bonded to the carbon, and the nucleophile is also, the upcoming nucleophile is also partially bonded to the carbon. That is the transition state. So after that basically what happens, the Br means the leaving group that leaves the system permanently and the nucleophile stays over there, right? This particular case, one thing I need to mention, if you start with an optically active alkyl halide, right, optically active alkyl halide, then you will expect one inversion in configuration. Means if you start with R, you will end up with S. You can see a tilt in the structure, a tilt in the configuration is taking place over here. Okay, and this is something that makes sure that SN2 mechanism that is happening. And another thing that I wanted to tell, backside approach needs to be very much clear in SN2 mechanism. Means, let's say if I have taken this tertiary butyl bromide instead of this, let's take this tertiary butyl bromide unit. In that particular case, the backside is completely hindered because of the presence of bulky group. So backside attack will be prevented or prohibited, right? So in this particular case, SN2 reaction rate will be slower. And about kinetics, it's a definitely second order reaction where rate depends upon both the concentration of the reagent, I mean the nucleophile, and the starting material. I guess it's clear. It's all about the SN2. Next, you can see catalytic hydration of alkenes. So basically, at first what happens, water in presence of a little bit H plus, catalytic amount of H plus acid, it forms protonated water. Okay, then this alkene group works as a nucleophile. This alkene double bond, this pi electron cloud approaches the hydrogen and it makes a carbocation out there and H2O is formed. Okay, after that what happens, the nucleophilic attack takes place over the carbocation. So now water plays a role of a nucleophile. Now water will attack on this carbocation and it will form this type of OH2 plus unit. Now what happens, deprotonation takes place. Now another water comes and takes up one hydrogen and it becomes alcohol, and H3O plus is regenerated in this process, and this H3O plus further works on another alkene. So these three steps are important. First one is protonation on alkene. Next one is it's a nucleophilic attack, and the third one is the deprotonation of the alcohol. So these three steps are mandatory. Let's proceed further. Here you can see dehydration of alcohol is also very much important. So definitely hydration will give you one OH unit, dehydration will give you back the double bond. So this OH will first get protonated and the first step is very much fast. Okay, so it will form OH2 plus protonated alcohol. After that what happens, basically this OH2 plus being a very good living group, it will leave the system and it will generate a carbocation, right? Then what happens, this particular carbocation gets stabilized by forming a double bond and the elimination of one proton takes place. Here you can see one carbon hydrogen bond breaks and jumps here and one hydrogen leaves the system. So first step is protonation, next step is formation of the carbocation, and the third step is the elimination of a proton to give the system some stability. I guess you understood. Let's proceed further. Here we will proceed with the formation of ether. So first step is quite similar. The alcohol gets protonated. Here you can see OH group is here and H plus, it takes up the H plus and it gets protonated. Next step, what basically happens, one SN2 type of reaction. Another alcohol unit, the oxygen lone pair, attacks over here, and OH2 plus being a very good living group, it leaves the system and you will end up with this type of system. Right, now what happens, now it's a release of a proton. So from here this oxygen hydrogen bond breaks, it gives the electron to the oxygen and the hydrogen is released and you will end up with some ether. I guess it's clear to you. Let's proceed further. One of the most important thing, that is a nucleophilic addition reaction on carbonyl. So if you are having this type of unit, it can be aldehyde, it can be ketone. So just remember that. So this is basically a planar. The carbon is planar. Carbon and oxygen bond is planar. And let's say here you are having one A, like any bond A, and here another bond, that is B. Okay. So basically what happens, planar structure is quite stable. Right, planar structure is quite stable. Now nucleophile approaches from the top or from the bottom. So let's take nucleophile is approaching to the carbon center from the top, right, and the oxygen bond is carbon oxygen, one bond gets opened up. Okay, so from the planar structure it becomes non-planar, rather tetrahedral. Okay, so nucleophile is approaching from the top, right? So it makes the structure tetrahedral. Okay, so definitely it proceeds through a tetrahedral intermediate. Okay, so definitely from the planar it is proceeding towards a comparatively unstable tetrahedral intermediate. So first step is the slow and the rate determining step as well. Second step, what happens? Second step, it takes up one H plus and it becomes OH, that is the addition product. Okay, I guess it's clear to you. This is the nucleophilic addition reaction on carbonyl. So now here you can see one of the most important nucleophilic addition only, that is the HCN addition or CN minus addition. So HCN in presence of OH minus, it forms CN, cyanide ion. So that basically again the same thing, just imagine here on the same plane, carbonyl, carbon and oxygen, from the above side, from the top the cyanide attacks on the carbon, from the below one carbon oxygen bond opens up and it forms a tetrahedral intermediate with the CN. Okay, now that tetrahedral intermediate with CN and another O minus, it takes up one H plus. So first step is definitely the slow one, because from the planar it is getting converted to a tetrahedral intermediate. Now this tetrahedral intermediate will takes up one H plus and it will form a very important compound, that is a cyanohydrin. Okay, that particular moiety is called cyanohydrin, where one single carbon is attached with one CN and OH, same carbon with CN and OH. This is called cyanohydrin. I guess it's clear. Let's proceed. Here comes another thing, Gabriel phthalimide. I already explained it is a name reaction, and the mechanism for this thing is very important for your board exam, for your KCET exam, both the cases. So what will happen first? Here you can see NH, this particular hydrogen is basically very much acidic, and this is you are giving some base. So acid base reaction, you will end up with some salt, right? Now this negative unit, this N minus will attack here, this will open up, right? As a result of this, NR bond will be created. Furthermore, what happens if you give some aqueous NaOH, then this bond will open up and you will get primary amine. So this is all about Gabriel phthalimide reaction. So here comes whatever we discussed, the entire reaction along with the reactants, reagent and product. Okay, so this is all that we covered, that is full there in your syllabus. So make sure you are noting them down and you are memorizing it. Better if you make a chart and you just paste it on your wall. Okay, so that's all, my dear. Please don't forget to comment below if you need such a rapid revision of the individual chapter of chemistry as well as from the other chapters as well. And yes, definitely subscribe our channel and don't forget to share with your friends. Thank you so much.